Right, now, so the next thing, okay, I wanted to just take you through an example of some real survey data. I'm not going to do every possible thing you could do with it, but I just wanted to use it to try and maybe tidy up or review some ideas that I've mentioned quite a number of times during the course. And I've chosen to do this because survey data is something that people that do business degrees, they usually find themselves working with at some point or another. And particularly if you're someone who's gone to university after school and you're newly graduated, it's often the kind of thing that you get asked to look at because it's assumed that that's something that university students learn how to do. So, I'll tell you, just give you a little bit of background about this data. So this is from something called the Household Income and Labour Dynamics Survey, and it has various components to it, but one of them is this thing called the retirement module. And it's a set of 8 questions. 8 questions, and it collects a bit of demographic data and so on. And it's a bit of a mysterious questionnaire in the following sense. I first came across it when I was chatting to one of our PhD students a few years ago who was doing her PhD on a topic which required her to use this data in a statistical model, and quite a complex statistical model. And she'd encountered a problem, which was that the model wouldn't fit. I said, well, look, let's have a look at, let me have a look at the data and see what we can find. At that time, I was taking quite a big interest in this whole question of how you measure latent constructs with questionnaires. And I was, learning about the kind of modern techniques for doing this, which haven't kind of diffused into every discipline, particularly not into management research. So we sat down with the data a few days later and went through it, and it had a number of problems that I could see, and I'll describe those in a moment. But one of the things I asked her was, well, this is a questionnaire that's supposed to measure a latent construct. So there's 8 questions in this questionnaire, and they're all, your typical strongly agreed, strongly disagree type Likert agreement questions, and you add up the numbers for the answers and you get a score. And supposedly that score is a measure of satisfaction with retirement. And that was what she was having a problem with, was getting that to function as it should as a measure. So I asked her, well, where did this come from? Has it ever been properly tested or validated, is the term we use, as a measurement tool? And so she went off and went looking, and I went looking too. And we never really got a clear answer. It seems to have been developed, if I remember rightly, in the 1970s by a husband and wife team of social workers. But there was never we couldn't find any documentation on it having been properly validated as a measurement instrument. But it's commonly used. This is conducted, I forget how often, but every few years, and quite large samples. The data I'm using here has about 1,230 people in it. So it's quite widely used, but it's not, on the basis of the data I have, I wouldn't say it's a great measuring instrument. So the questions, so they're all in the form of statements to which the respondent has to say whether they strongly agree, neither agree nor disagree, and so on. So things like retirement has been better than I expected. So these are the subjects of this. The data I have here are people who are 45 years or older and who self-report as having retired. And the data is taken from what are described as husband and wife pairs. Okay, so half the data is husbands and half the data is wives. I won't be using that well, actually I will. Don't, but I won't be looking at pairs in what I'm talking about here. Now, as is quite commonly the case with these things, there's two features that I regard as a little bit questionable. So one of them is it has this middle term, this so-called neutral term, neither agree nor disagree. I think I've said to you before in this course, my advice is avoid using that if you can. And the reason for doing that is that it tends to mess up the measurement, and that's because people who choose that option, some people choose it because their level of agreement really is somewhere between agree and disagree, and some of them choose it because they don't understand the question, or they don't want to answer the question, or they don't know, or whatever. Okay, so it becomes a very noisy level on the questionnaire. My view is it's better to not have it and give people some other way of dealing with that problem of not wanting to answer the question or not knowing the answer. The second thing that is a little bit tricky is that some of these questions are worded in the negative. Okay, so I have real concern about my financial situation. That's negatively worded compared to the first one. Retirement has been better than I expected. Now, when we process the data, we switch the numbering around basically to take account of that. But sometimes negatively worded questions can misbehave in terms of measurement as well. The reason it's done like that is often, it used to be believed, and maybe some people still do believe this, that if you only have positively worded questions, then you will get respondents who just go through and tick agree for everyone. Okay, they don't think about the answers. And so the theory is if you have some negatively worded ones in there, people will think more carefully when they're answering. I'm not convinced that's necessarily true, but there you are. Okay, so 1,236 responses, so that's a pretty good number. It's a good sample size. Now, when I first looked at this, my initial interest in it was because this was the PhD student's problem was, is this thing producing the sort of data that she needed, which was interval level? Okay. But the modern way to approach this is the first thing you do is you check to see whether it's even ordinal level. Okay, and if it checks out as ordinal level, then you start checking to see if it's interval level. So when I ran that initial check, what I found was that it was sort of barely ordinal. Now, what does barely ordinal mean? What it means is that if two people, for a start, if two people get the same score for over the 8 questions, if you add up the scores for the 8 questions and two people get the same score, doesn't necessarily mean they have the same level of retirement satisfaction. But also, if one person has a higher score than another, it's not necessarily true that that person has a higher level of retirement satisfaction. Whereas if it was a properly ordinal scale, then a higher score would always mean a higher level of the latent construct being measured, which is retirement satisfaction. Now, the process for how you actually test for this is quite complicated, and I'm not going to go into it, but the result of testing this data was that it was, at best, weakly ordinal. So it was pretty noisy, and that was part of the problem that she was having. But there was other stuff going on. So I then went on and had a look at broke it down to these actual levels of strongly disagree, neutral, and so on. And here's what I found. So these things here are the names of the variables. So they're these names here. Okay. So what I found was that, with ACF, if you take the questionnaire as a whole, the neutral category, choosing for that question, actually indicated stronger agreement or stronger retirement satisfaction than choosing agree. So agree and neutral were kind of swapped around in terms of their ability to measure retirement satisfaction. And that was true for nearly all of the others. There was one here where, which was it? Oh, this one. So AER was a real mess. So agree, people who ticked agree here basically measured the same amount of retirement satisfaction as disagree. And the neutral category corresponded to a higher degree of retirement satisfaction. So that was AER was a very messy one. AER, what is it? I enjoy being retired. Yeah. So there's a problem there with that. The problem was mainly with that neutral category. Okay. That was messing things up. So it was clear that there must have been a whole lot of people in that sample who, if they chose the neutral category, it wasn't because they had a level of satisfaction between disagree and agree. It was because they didn't know, or they had something else going on, or they didn't want to answer the question, or they couldn't understand the question, or something like that. Okay. And then so that was one set of problems. The other problem was there were two items. These two. People don't respect me as much now that I'm retired, and I wish I'd started to plan for retirement earlier. They didn't fit with the others. So what that means is there were quite a lot of people who may have scored high on the other questions and low on those two, or high on those two and low on the others. So they weren't moving in tandem with the rest of the questions in terms of measuring retirement satisfaction. So the way we would describe this is we would say they are probably measuring a different dimension or a different, possibly even a different latent construct to the rest of the questions. They don't fit. So normally if you're developing a questionnaire and you actually want it to measure a latent construct, you do a lot of testing. You do repeated tests to identify items like this and fix them or remove them. So what I then did was test the data removing those two. Okay. And that worked quite a lot better. Okay, so yes, Sarah?
When you say you're testing latent constructs and you do repeated tests, how many times would you do the test to remove the noise in the data?
Well, it depends how good your initial set of questions are and how many you can get away with asking people. So I've seen cases where, their aim is to get to a set of 20 questions and they start off with 90. And then they get a few hundred people to answer the 90 question questionnaire. And then they do the analysis and they weed out a whole lot. And then they test the reduced one. So maybe 2 or 3 times like that, but you need a lot of subjects to do that. Where you see this particularly done is with patient outcomes questionnaires in medicine, because for many medical situations, you want to get a questionnaire that's as short as possible, but still gives you good measurement. So if you want a questionnaire to measure pain or mobility or things like that, they typically need to be very short. If you look at the established pain questionnaires, they're designed for people coming into emergency on a stretcher. And you've got to ask people 5 questions and get a reasonable idea of the level of pain they're in. So some of those go through a lot of testing, and practitioners keep testing them. But you don't tend to find that so much in this kind of managerial domain. There certainly are questionnaires that have been around for a long time and were thoroughly tested to begin with. And every time someone uses them, they will often report they won't do a full analysis usually, but they'll report a couple of statistics that give you an idea of how well the questionnaire performs. So, the thing with this particular one is if you just use a simple, so there's a statistic called Cronbach's alpha, which is the usual thing that gets reported. And, this questionnaire, the full 8 questions have an alpha of about, I think it's about 7.4. And that's regarded as acceptable for research in social sciences and psychology and so on. But it's actually not very high. I mean, that number is also calculated for things like HSC exams, and there the expectation is that you'll get well over 0.9. Okay, they set a much higher standard for exams than they do for scientific research. But it's very strange if you compare it to the physical sciences like chemistry and physics, where researchers spend a lot of money and pay a lot of attention to getting very precise measurement. Whereas in the social and behavioral sciences, we have what to me seem to be really pretty lax standards for measurement. So to give you an idea with this one, the maximum score you can get is 40, okay? So the scores range from 0 to 40. So I did a calculation to work out the standard error of measurement of this questionnaire. And the standard error is 2.5. So what that means is that if a person gets a score of 30 on this retirement satisfaction questionnaire, then the 95% confidence interval for their score is between 20 and 40. Is that right? No, 25 and 35. Okay, it's 5 points either way, which is pretty wide error margin. But that's pretty widely accepted. So anyway, I removed these two because they really, whatever it is they're measuring, it doesn't seem to be what the other questions are really measuring. And taking them out does significantly improve the questionnaire. So the questionnaire is now, it's a reasonably good ordinal level questionnaire. Is it interval level? Possibly not. That's a little bit harder to establish, but pretty borderline, I'd say. But having said that, people commonly do regression with the results from this questionnaire. So they're assuming it's interval level, and it might be near enough. I don't know. Now, the analysis went a little bit further. So I had a look, even though it was now an okay questionnaire to produce ordinal level data, I studied a little bit further, and so the remaining questions actually divide into 2 groups. So they're both about, satisfaction or comfort with retirement, but there are these two don't fit fantastically well with these 5. Okay, so these ones are clearly about financial comfort, and these ones are about other things. And so this is a situation we often find with questionnaires of this kind, that they may have you can identify a couple of dimensions in them, and what you have to consider is, it doesn't really matter. Do we just use a composite score, or do we separate them out? And I think in this case, it's probably reasonable to use the 6 questions together, but you can sort of fairly clearly see that these two are not quite measuring the same thing as this. And you see, one of the problems with measuring latent constructs is you're kind of working in the dark, because you don't have anything to reality check directly against. You can't connect electrodes to a person to measure their financial comfort or their retirement satisfaction, and then see if your questionnaire is giving you the same answer. Okay, that doesn't work. So you have to try and reality check against, you might use other things that you would try to reality check against, like, I don't know, people's anxiety levels or something that might be related to retirement satisfaction. But what I would really want you to just take away from this is that you can't, if you just, you know, cook up your own questionnaire, or somebody you work with or a consultant or somebody just makes up a questionnaire and they don't do any testing and validation of it, then you can't assume that just adding up the numbers for the answers to get a score is really producing a measurement of something. It might be, it might not be. You need to be fairly cautious about that. And this is something that actually becomes a practical problem in a lot of situations in work. So where you see this a lot is in recruitment, where someone in the HR department makes up a bunch of questions to ask candidates for a job, and the questions are asked, and the members of the committee give scores for the answers, and they get added up, and then the person with the best score gets the job. But the problem is, the score could be rubbish because it's probably never been tested or validated. But people do that all the time. Another HR thing you get quite a lot is various kinds of performance rankings. You get supervisors to rate their staff on various criteria and so on, and then they get added up and used to calculate bonuses and things like that. A lot of that sort of stuff is probably fairly nonsensical. Okay, it's just people making up numbers and playing around with them, and they don't necessarily measure anything in a meaningful way. But it goes on all the time. Okay, now what you can do with questionnaires more reasonably is you can just do analysis of individual items without worrying too much about summative scores. So what you have in this kind of questionnaire typically is you have you very commonly have these Likert style questions with agreement scoring, or you may have questions where people rate something on 1 to 5 or 1 to 10 or something like that. They are all producing at best ordinal data. So you can there are some things you can do with ordinal data, and we haven't really talked about them much in the course. The data in this questionnaire looks like this in its raw form. There's some bits I haven't shown you here. So there's an ID number for each person, and there's also an ID number for each husband and wife pair, and then things are recorded as numbers. Okay, so 1 is strongly disagree, through to 5 is strongly agree, and then some of them have to be reverse coded. So I think, for example, I'm pretty sure ALW is a reverse code, isn't it? Where are we? Okay, ALW. I would like to still be working. So that has to be negatively coded because that has a negative relationship to being satisfied with retirement. So the way you negatively code, if we look at ALW here, so where are we? So 3 there. That's the neutral, the middle number. So what we do is we've got 5 possible values from 1 to 5. So all you do to reverse code is you subtract from 6. Okay, so you add 1 to 5 and then you subtract. So 3 from 6 is 3, so that stays as 3. 2 from 6 is 4, so that becomes 4. 1 from 6 is 5. 2 from 6 is 4. 1 from 6 is 5. 1 from 6 is 5. So that's how you reverse code. Now, here's some box plots. So these are box plots. These are just for the responses for the 8 questions. This is the data here is not reverse coded yet. You've got to be a little bit careful using box plots because you've only got 5 possible values, but they can quickly show up if there's a strange shape to the data. So the obvious strange one here is AWA. So AWA is, where are we? I was well adjusted to the change, I presume the change it's meant to be following retirement. Okay, so what that's telling you is that apart from a few outliers who scored strongly disagree, disagreed, neutral, or one that has scored strongly agree, everyone else said agree. Okay, so nearly everyone agreed that they felt well adjusted to retirement. Now, some of the others here, so you've got a couple there, ASP and ADI, they're just sort of totally boring vanilla box plots. But then you've got some here that are missing a quartile, so ACF and then, you know, Q1 there is the same as the median, and then with AB, Q3 is the same as the median. A couple of outliers here on AER. So it just gives you a bit of an idea of what's going on with a question. You know, if you see something like that, you kind of want to know what's going on there. There doesn't seem to be much of a range of opinion about that, and maybe that question isn't giving you much. Well, that question won't be giving you much information. So if nearly everybody's giving the same answer, that question's maybe not contributing very much to your measurement. And that's one of the reasons you might review keeping that question. Now, we can also look at correlations with ordinal data. So the common methods there's a couple of them. They are variants of Pearson's correlation coefficient. I won't go into the details, but basically they involve the common one, Spearman's, which I've used here. Essentially what it involves is that you rank things and then you use Pearson's correlation on the rankings, but the interpretation is exactly the same. Okay, so there's a table of correlations there. This is the unreversed data. Okay, so this is still, I haven't reversed the negatively worded questions. So I've got a table of correlation coefficients there, and what you see, I'm sure you've seen these now in articles. So you have a diagonal line of ones down there. Okay, so everything has a correlation of 1 with itself. ABE with ABE is 1, ACF with ACF is 1, and so on. And then you've got the other correlations. You only need one of those diagonals. You don't need both. And quite often in journal articles, they'll just have a table that just has the one diagonal. And there's a visualization. This thing's called a correlogram. So it's just a way of visualizing correlations. And I've used a little artificial intelligence routine to sort of find the order of variables here that gives you the clearest picture of the correlations. So here, these dark blue ones are the intensity. The blue color means the strength of positive correlation, and the intensity of red means strength of negative correlation. And so what you see, AER, AWA, and ABE, these are, if I remember correctly, these are the sort of general satisfaction questions. Let's go back to the question. Actually, I'll put them down the bottom. Yeah. What is it? AER, AWA, ABE. Yeah. Retirement has been better than I expected. AWA is I was well adjusted. ABE is sorry, that's ABE to the bottom. Was it AER? I enjoy being retired. And then there was a fourth one in that general satisfaction with retirement category, which is ALW, but that's a reverse coded one. So that's in this unreversed data that turns up down here at the negative end. Correlation heat map. It probably is, Bianca. I know it as a correlogram because that's what it's called in the R package that I use to produce it. But so for those that are not familiar, a heat map is a kind of visualization, a diagram that uses different color intensities to represent the intensities of some kind of variable. In this case, correlations. So the main purpose of this is you can sort of look at it, and it's just a way of, this is an exploratory data analysis tool to give us sort of an idea of where there might be patterns of relationships between variables. Now, the next set here, this is after the reversing of the negatively worded items, and it's essentially a similar pattern, but it's moved some of these variables around. So you've essentially got you've still got your general satisfaction cluster there, and then you've got your financial satisfaction cluster there. I think that's correct. Yes, and then you've got so these are the two that I said don't really fit. And as you can see, they're not really terribly strongly correlated. Now we'll just look at some individual items. So what I'm using here is the techniques that I've talked about in last week's lectures, and this is the kind of thing you're doing in your task write-up for test 4. So what you can do is look at, when you have this kind of ordinal questionnaire data, is you can compare pairs of things. So the first comparison here is we've got this question ABE, retirement has been better than I expected, and we also have a variable which is husband-wife. So the question we're looking at here is there a difference between husbands and wives in terms of this particular question? And so you can deal with this in the following way. You've got this problematic neutral response. So what I've done here is I've sort of just thought, right, I'm going to discard the people that responded with that neutral response for the purpose of this particular analysis, and only work with respondents who gave a clear answer of agreement or disagreement with that statement. Okay, so the idea I'm working with here is that neither agree nor disagree is not really a measurement. It's kind of a noisy bucket to catch people that, not really sure what they want. Sarah, is this another way of looking at game theory? I don't think so. But so in game theory, goodness, what do you call them? You have those outcomes tables, don't you?
Like if the husband makes a decision that they're going to go to the theatre, so the wife says,
"Yeah, I know what you mean."
Going to ballet.
Yeah, it's not the same thing, but I'm just trying to think if they actually count as, they don't. I can't even remember what they call them now. It's a long time since I've looked at game theory, but I know what you mean. They do things that look like contingency tables. I'm pretty sure they don't call them that. But they're tables for documenting the possible outcomes. No, this is just based on counts. So basically there were 372 wives who had a positive response, agree or strongly agree, 346 husbands who had a positive response, and then 69 and 85 respectively who had a negative response. So we can just put that into a contingency table. This table here, so these are the same thing, but this has what we call margins added. In this case, the margins are totals. Okay, and we need those totals if we're going to do certain types of manual calculations, but I'm not suggesting you do manual calculations for these things. I've given you a spreadsheet to do this, and you also have a link in the lecture notes last week to an online calculator that'll do the same thing. Okay, so we calculate there's an odds ratio of 1.3. So the odds ratio is just calculated by multiplying those two numbers and dividing them by those two numbers. That'll give you the odds ratio. And all it's saying is that what this is saying is that the odds of a wife giving a positive response are 1.3 times greater than the odds of a husband. 1.3 is not regarded as a very big odds ratio. Okay, it's not something to get terribly excited about. The second thing here is this statistic called the phi coefficient, and that's interpreted in a very similar way to Pearson's correlation coefficient. In fact, for 2x2 tables, it's essentially the same thing. So that's very small, 0.05. But the important thing here is that the online calculator or the spreadsheet that I've given you, you can calculate a confidence interval for the odds ratio. Okay, so an odds ratio of 1 means that the odds of a wife giving a positive response would be the same as the odds of a husband. In other words, there's no difference. The 95% confidence interval in this case is 0.93 to 1.9. So that 95% confidence interval contains an odds ratio of 1.0. So that means we can't claim that we're 95% confident that there's a difference between husbands and wives in the broader population of retired husbands and wives who would respond positively to that question. So I'll do another one with husbands and wives. So this time it's this question is, people don't respect me as much now that I'm retired. And again, we've got the contingency table there with the margins. Now, in this case, the question is negatively worded, okay? And what we're interested in, our dependent variable here is the question, okay? And the independent variable is husband-wife. So we always set the contingency tables out like this, and we have the outcome that we're interested in, which is a positive response. So a positive response here, what that means is agree or strongly disagree to that question. Okay, so it's actually a negative feeling about retirement, but it's a positive response to that question. So what we get here is it's a fairly weak odds ratio again. So this is 0.67. So 0.67 is less than 1. So what that's telling us is that it's the odds of a wife saying agree or strongly agree, a positive response to this question, are lower than the odds of a husband giving that response. Okay, again, it's not a very strong odds ratio. The phi coefficient, the correlation coefficient, again, quite small. It's negative, as you'd expect in this case, minus 0.06. But in this case, the 95% confidence interval just squeaks in, okay? So it runs from 0.45 to 0.99. So it doesn't quite include 1.0. So we can claim that we're 95% confident that there's a difference between husbands and wives on this. And specifically, we can claim that wives are less likely than husbands to believe that people don't respect them as much now that they're retired. Okay, let's look at one more. So this time we're comparing two questions. And trust me, if you haven't done this before, this is the sort of, when you're designing a questionnaire, so if you were given the job, which some of you may well be at some point, to design a question to find out something about, customers, or you might be in a HR department, you want to find out about people who work in the organisation. You actually, when you're writing the questions, you ought to be thinking ahead about what kind of analysis would I do with them? What kind of questions would I be answering with the data from the survey? And that means thinking about what tools you have available, reasonably robust tools like these ones to analyse the data. And, so this is fairly typical, 2 questions, okay? So this is not about husbands and wives, this is just a relationship between 2 questions. So there's a question about wishing you'd planned earlier for retirement. Okay, so that's going to be the independent variable. And there's a question about retirement has been better than I expected. And you can think of that as being the dependent variable. They're not really independent dependent variables probably, but just in terms of the way we normally organise a 2x2 table. Okay, so again, I've converted the 1, 2, 3, 4, 5. I'm just looking at the people that scored 4 and 5, agree and strongly agree, and the people that scored 1 and 2, disagree, strongly disagree. So this time, again, we get a fairly weak odds ratio, 0.65. The phi coefficient is pretty small. It's a little bit bigger than the previous one, but minus 0.08. So that's a small correlation. And again, the 95% confidence interval just sort of squeaks in, so it doesn't quite include 1, 0.44 to 0.96. So again, we can claim that we're 95% confident. That's a difference here. Yes, Sarah.
What happens if you get a really strong odds ratio, like 4, basically?
Well, you get excited. You got a strong finding. It turns out I actually went through and did all of these. None of them are terribly strong. Which surprised me, actually. This one in particular, I thought this might be very different. Okay. I can't remember exactly when this data is from, but it's not super recent. If it was super recent, they would be using different terminology to husband and wife for a start. So this might be 10 years or 15 years old. I can't remember. But I thought there would be a bigger difference between men and women. I was expecting that a lot more men would have this view about not being respected when they'd retired. And I was partly influenced in that thinking by the sister of I have a colleague who's an academic, and his sister is an academic, and she studies retired people, and her particular area of interest is retired people who volunteer to do stuff. And what I remember going to a seminar she ran once, and she said there are so many men who retire from professional jobs, accountants, lawyers, and things like that, and they want to volunteer, but they only want to volunteer into high status things. So they don't want to go to the op shop, the charity shop, and sort clothes. They want to be on the board of the charity shop, or they want to be the accountant for the charity shop. And so there's actually a big disconnect for what the demand is for volunteers and what you can get. And that at the time that struck me, this is and I can sort of relate to that, but this is probably partly about people who are retired and used to have jobs with some status and prestige and so on attached to them, and then they're looking for some way of regaining that in retirement. But actually the difference here is pretty small. But one reason this kind of method is a safe one for dealing with these kinds of questions is, with real questionnaires, you will sometimes find that you'll have a question and nobody chose strongly disagree. So that one's just doesn't even appear in your results, or no one chooses strongly agree. And so it actually works quite well to just say, okay, we're just going to break it down into agreement and disagreement. And then you can, if you do that, then you can do the 2 by 2 table analysis. Because I think you'll find, particularly those of you that are, maybe going into your first full-time work after graduations in, office type environments, is you may well, have to look at questionnaire data, and it'll often be questionnaire data that doesn't have very large sample sizes. If you've got a questionnaire with 1,200 respondents, in general, you'd think it pretty unlikely that for any question you would not get at least some for each of the 5 categories of response. But as we saw with one of these questions, nearly everyone just chose agree. There are only a very small number who chose other answers. And if your sample size is 100 or 50 or something, you might get very lumpy kind of data. And this kind of way of analyzing it is fairly straightforward. And frankly, it can be easier to explain to an audience if you're just talking about agreed or disagreed, rather than producing charts and things that are trying to make claims about 5 levels of agreement and disagreement and so on. Depends on your purpose. Now, what I haven't done here, but at the end of the notes for week 11 for last week, I gave you an example of calculating confidence intervals for differences in proportions, and I made the point there very clearly that I'm not going to test you on that, but I would like you to remember that it's a useful technique, because you can use that here too. Okay, so you've got a proportion of people here that wish they'd planned earlier, so that's 238 divided by 304, and a proportion who don't wish that's 333 divided by 393. So you can do differences of proportions and confidence intervals for those. And a difference of proportions is actually quite a straightforward thing to explain to an audience who's never heard of an odds ratio. Because if you're delivering results to an audience like that, you might want to have these in a footnote on your slide. But what you probably just want to be saying is that you don't want to even mention odds ratio. You probably just want to say that you're 95% confident that there's a difference. Okay. So, think about that. That technique for confidence intervals for differences of proportions, it's really useful. It's a little bit of a fiddly calculation, but it's not that bad. And there are just lots of situations where it's a handy one to work on.